Hello Earth! Welcome to episode 28 of Making Cell, a series of videos where I record myself designing and implementing a programming language and environment called Cell. So this is episode 28, so if you're just tuning in, I recommend you take a look at this page here, github.com, autocode.nl/cell, I'll put it in the description, or you can just go to video 1, otherwise you can of course keep on watching. So we are still getting the entire language to work, and yeah, we're making some good progress. We have a bunch of functions that do our lexing and parsing, basically the splitting of text into meaningful, let's say, lines, actually into paths. Basically, that's a good way to put it, actually. The splitter basically takes text and converts it into paths. Yeah, we did that. And then, yeah, so we did the splitter function. And then we have this dedotter that we did last session, which I think works quite well. And we actually even tested it already, because tests are key. And whether we like it or not. And then we have the sorter, which I think we also tested. Yeah, we made a lot of progress. I'm impressed with our past selves. So now the validator, yes, and then the validator I was struggling, but I cheated a bit because I was thinking about this problem, and I made some notes about how I think we can fix the validation. So I think I have it. So let me explain it, because I put it here in this very rough notes. Am I recording already? Yes. I always have to check OBS. You never know when it might stop recording your screen. So this is my thinking. So you have a number of paths, right? Let's just take something from Todis, like here. So it's not that I'm using a deep voice on purpose. It's been a week and a half of going back to Argentina, my home country. So a lot of drinking and overeating. So my voice is telling the tale. So yeah. So let's just look at these paths, right? So you would have something like, if you had the actual paths written, because they're basically, have them separately in the representation, the internal representation, or the representation of the splitter, you have something like this. So let's just look at these three. So the first thing to notice, well, not to notice, to check, is that, okay, you go to the first line, right? The first path. Actually, it's not a line, it's a path. And to start using the proper terminology here. So you go to the first path, and you see that the first thing, the first element of the first path is text. Therefore, if you're assuming a consistent whole in these three paths, the entire thing is a hash. Why? Because the first element of the first path is text. If it was a number, it would be a list. And so you can see that the n+1 element determines the type of what's at n. So the next element determines the type of the previous element. That's a really interesting result. So I put it here. The type of the nth element is determined by the well, not the type, but by the next element. And then basically what I will try to say here in a very cryptic terms, well, not cryptic, just I didn't explain properly, is that if n+1 is the last element of the path, then n will be either text or number. If n+1 is not the last element of the path, then n will be either apologies, a hash or a list, depending on what's n, right? So yeah, that's what I want to check. And I figured that what I can do, moving on to the, I'm sorry, so basically you check that the overall thing is hash, right? So you check that the root is a hash. Okay, good. You don't check actually, you see. Okay, the root should be a hash, then request has headers after it. Headers is text, is not the last element, therefore request should also be a hash. So then I mark it as, okay, request also has to be a hash. And then I move to request headers. What comes afterwards is accept, which is also text, therefore request headers is also a hash. And then you keep on moving, you move on until accept. And then accept, the next element is application JSON, which is text, but it's the last element of the path, therefore accept itself is text, because it points to the last value. Interesting, right? And then I'm done with this path. So then I start with the next one, which is request. Again, first element. So I assume that the entire thing is a hash. So I go to see if I have already a type for the last, for the entire thing. Do I? Yes, it's a hash. Does it match with what I have here? Yes, it matches. Therefore, there's no error. And then I do the same thing with headers, and I check that the request is a hash, which it is. And then you keep on going. And then let's say if user agent were to be something else, then I would have an error, right? Sorry, if user's agent was, let's say, a number, I never saw it before, therefore it will not create an inconsistency, which is perfectly fine. And then if let's say here I will have something like 2, then when I go here, it's like, wait, this is telling me that the overall thing is a list, but I thought it was a hash. So then I can report the error, and that will cover it. This algorithm, we can even make it detect duplicates, because if we do something like request host foo, so here there's no type inconsistency, but what I can do is, if I have an entry already for the same prefix, and this prefix is basically something that, prefix is the leftmost part of a path. So if I already have an entry for that, and that's already something that has nothing to the right, then it's a duplicate. So I think we can do everything, even that thing that I put on the previous episode. Where is it? No, it's not here. Where did I put it? Well, it doesn't matter. Let me just write it. Oh, I'm an idiot. It's right here. Sorry. Oh, sorry about that. So foobar, fooyip. What I didn't like about this is that, wait, foobar, sure, by itself tells me that foo is a text that is bar, but it could be foo and yip. This is like, you could see it as a hash that is missing things, but you could also see it as an overwrite. It's like foo is either bar or yip. But this type of malformed thing and this rule about forking, I can just represent it with types. So foobar is text, and here foo yip is also text overriding foo. Therefore, it's wrong. Yeah, that it's good. It will validate it. So hopefully that's semi-coherent as usual, and we're good. Let's just get rid of this and get cracking on the validator. So I'm just going to have a hash called scene, and because I live in 2001. Do I live in 2001? Yes, I live at the time of JavaScript ES3. It should be compatible with ES3. Because if we are able to run cell in Internet Explorer 6, I think we will find a degree of self-realization not achievable otherwise. So I don't use a map, I just use a hash or an object, because why not? We need 4 types, right? So here I'm going to put all the prefixes, and then I'm just going to go and iterate these guys. Actually, we're going to do it like this. Like so. So we're going to start with the root always. See, if I'm looking at the first element, V will be the path. No, it will be the first line, sorry. The first line, no, I don't need a special case for that. So we have that. I was thinking whether I should create a new variable here or not. It wouldn't matter in JavaScript, which gives me a good hint about things that can fault or not. Yeah, it really doesn't matter. I could also do it like this, because during the context of the execution of the thing, you'll be fine and it will be returned yes. I still feel more comfortable about doing that. I am paying attention to those details because very soon we're going to be in the thick of doing these things in cell itself. So insight is appreciated. And this is a stop. We'll stop at the first error. Why don't I call this line? Actually, it's not a line. Why do I call it lines? It's paths, right? Why am I doing things wrong? Let's use the proper, like, I'm not being Confucian enough. Proper naming. It's the key. It's paths. Come on, it's paths. Good, good, okay. Take it easy. I don't need that guy, the index. So yeah. Have that. So what? So what do I do now? Okay, so we're going to do it like this. Now, if I'm looking at the first element, actually I can do it here, of course. At the beginning, I just look at the prefix. So I assume that paths have at least length 1. They have to, right? You could never have a path with length 0. They're just not produced by the splitter. Whoa. Should I just call the splitter a pather? Actually, yeah, because it really paths things. Why not? Things I do to feel productive. Sure, okay. It's remarkable how, because I'm really hopeful that this will work, this validator with this idea. When you have the right idea, how well it can go. Okay, was I here? Yeah, so let's just look at it. So if, no, we can do it like this. A path. And could the entire data space be text? Only if you had one path. Well, the entire data space you're looking at. Because the data space is relative, right? It's just it is connectable, but in itself just one thing. Sorry, but in itself, yeah, one thing. So you could have an entire data space that could be just text, and then you could put that inside a bigger thing. But if you have two paths, it cannot be text because you have two. So you either have an overwrite or not. Wait, no, I think the logic is the same. I don't have to do special logic here. So it's like if I only have a path of length 1, then the entire data space, if I'm looking at the first path, would be a number or text in itself. No, it's the same logic. It's the same logic. So maybe I can do it for the previous one. Oh, with a slice. Yeah. So we can do it like this. Look. So when I'm looking at the element 0, I'm checking against the root. So I would do something like this. It's I need to get this terminology in place because wow. If you're looking at the first element of the path, then it's well, if I was feeling Chomsky, I would call it a non-terminal because it's not the rightmost element, and then I also just call it a terminal. But I don't like those terms, so I could call them keys and values. I guess you could have multiple keys and a single value. I kind of like that asymmetry. It's almost reminiscent of, Lisp with the current CDR, except that instead of getting the first element versus everything else, I'm more like getting everything else to the left and the last element. Yeah. Okay. Well. Yeah. So let's just do it. So if I'm looking at, then it's a key or value. So it will be if k plus 1 equals path. Okay. So if it's a key, I kind of hate this variable name. Let's call it what? Interesting how sometimes what's like what we call the type really is almost defining a thing. It almost reminds me of how the name itself of a thing is sometimes considered to be the thing itself. The finger pointing to the sky is the sky. And if it is a key, then I would just do it like this. Scene path slice at k joined by, actually I can just stringify it because that's going to be unambiguous. Boom. Wait. Then we can just call it the scene key. So this is going to be, for example, that. Yeah. And that's unambiguous, and I like it. So if there is no scene key, we do like this. Scene key equals to what? Actually, we can just make it what value is, what type is determining, right? And just be done with it. So let's just do a nice nested ternary just to wait, I need to do more things. Actually, this one is really good. I need this one here. Let me put the song that just went through again. No, that's not what I wanted. Perfect. Nice tango from 1989. So if the type of B is a float and k plus 1 is exactly its path length, return. It's not a line. Why do you say line? That's just wrong. And also here. No. No. Place it. And this goes away, and this case of the checks for duplicates. Yeah, this prefix algorithm solves all the issues. I'm really happy about it. Get that cozy feeling. Yeah, sure. I think that's good. Should be Teishi type, right? Yeah. Yep. Yeah. So type of B is string. Actually, we could do the other one. If it's text, then it's this whole thing. So we only make one call to the type function, which is more expensive than the other one. So if it's string, then k plus 1 equals, actually let's do it less, then it's hash, otherwise it's text. Yes sir. And this one is as simple as list or number. Can I do it like this? Sure, why not? Yep. Yeah. Good. Perfect. If there's no entry, put the entry. Boom. Set it to the type. Otherwise, this is where it gets interesting. Two things, duplicates and inconsistencies. So if scene key is not the type, we have an inconsistency. Path, not line. This path is setting a what? A type. I'm gonna make a bad error message and then we can improve it. But there is already this is a typical error message that makes you see red as a user from that path. We can later improve it. Okay, we have that. Otherwise we're fine. And then if type is number or type is text, return repeated this path is repeated. Wait, is there such thing as a path? Now I lost it. Yeah, it's a path, exactly. Yeah, perfect. That's it. That's really it. I think that's it. Now we need to test. If error, return error. We can do it like this. For shizzle. Okay. So let me switch albums again. Well, not albums, just music. Let's do the tests. Wait, first of all, is the refrigerator still running? Boom. Yeah, nuts. Yep. Okay, better. Okay. It's already failing at the first test case. Let's just fix it. Path foo. Oh yeah, because I need to stop at the last element. Yeah, right? Wait. Yeah, I cannot be doing the last one. Oh yeah, I'm doing the last one, but yeah, let me just do this. I need to see. No, not here. Here. Wait. Let's do one at a time. Okay, that one did work. All right. Okay. This one's the one that's failing. Oh, it's just a matter of the error. Yeah, it didn't validate this. Why? So we need to put a cloud. So to know where it starts. Okay, here. Why is it not creating an entry for foo? It should create an entry for foo. C key. Yeah, you start with the whole thing. I have it wrong, right? I need to slice up until that one. Yeah, of course. Yeah, right. Yeah, so, and I need the empty one too, right? So this is hash. Foo is text. Ah, that's it. Okay, now we have it, right? Yeah, that's it. Yeah, it's from 0 to k. Yeah, of course. That's what I want to do. It's like longer and longer paths or subpaths. Subpaths, I guess. Brilliant. Okay, and now, so let's just look at it. So, yeah, because foo is considered to be text, and then suddenly I am very silly sometimes. All that talk about creating a new variable, and in the end, that's what I need to do, right? Yeah. Okay, now it's just a matter of the error. Yeah, we need to fix this error. It's just fucking annoying. Like, you don't even know what it is. At least do this, you know? There's already a... No, did I just close it? My god. Ah. But there's already that path. And here I can do synckey. Well, I can just do it like this, right? Path slice 0k, join space. Yeah, that's better. So now let's just fix the test. Well, not fix it. Yeah, fix the test, I guess. Why don't you copy? Yeah, okay, so now, good. One more. Yep. I like this. I'm very happy with this. Because I think it works. Nope. Close. Close. Let's just remove the noises. And just change the record. No, common mouse. Where's it? This one. Yes, sir. Really good record too. All right. Now validator. I am very happy with what's happening here. Yep. Yep. Look at that. All tests successful. That's very nice. And let's just go with, let's say I just have something like foo, like a single value. Love those corner cases. Yes. One. Would I ever have an empty one? No, it would be just like that. Yeah, that's a good one. And this, where I have a foo, and then a one, would give me an error, of course. Take a breath, life. Yeah, all right. Wow, okay. Yeah, I'm very confident in this. And if I just go back to episode 16, which is receding into the distant mists of the past, validation, no, that already we overcame. You cannot mix types, you cannot have repeated things. Well, actually the repeated one I came up with later. Yeah, amazing. Yeah, I think we covered everything. Let's just I want to do one more. Yeah, I think I never did the the repeated one. No, what am I doing? Foo, then var, then foo, then yip. Let's see what was the error, because I'm lazy to. This path is repeated. Yes. Well, should I put the quotes? Should I? Yeah, I should put the quotes. The path once it comes for round, day by day survival. Yeah. If you thought this couldn't get worse, it did, because I just started singing. So what is your problem? Oh yeah, sorry team. Yeah, Mr. the Light. Okay, good. Wow, we're done. Yeah, look at that. 20 lines. Yeah, 21 lines. Okay. Great. So let's just take a bit of a step back and see what we built. It took us what, 12 episodes, 13 episodes, probably 10 hours to build. It's just ars longa, vita brevis. But hopefully, with a bit of Brian Johnson and current technology, we'll be able to finish Cell on time to do many other things. That's my hope. So let's just take a step back and look what we did over the last 12 episodes. We have text. That's fourdata text that is being converted into. It goes to the parser, and then it's do I call it sorter? Yes. Well, dedotter, sorter, validator. And once it's validated, you have a number of paths. That's the outcome. So with these paths, what do we do? What do we call this entire process? This is the real parser, really. A parser will either give you an error or will give you paths. Yeah, right? Yeah, because I am pretty convinced that the, let's say, lower level internal representation of data in cell is going to be a list of lists, which is a list of paths, Yeah, let's just write that down. That's a good one. The internal representation, canonical is just too much of a word. Just the internal representation of for data inside cell is going to be a list of paths in the cell totis sense. So when we write macros, which hopefully will be soon and will be fun, season 2, season 3, we will operate on these lists of paths. That's where we're going to operate. So the parser it gives you paths or an error, validation error. Yeah, brilliant. We have the proper parser, right? I need to remove these comments. I think when we're done with them, takes text, presumably as for data, there's a list of paths. Okay, that's it. So I have the pather, dedotter, sorter, validator, and now we have the parser. By the way, the pather can return errors, right? I believe so. Oh yeah, of course it can. Sorry, I forgot about the last month of my life for a second. Yeah. The dedotter and the sorter do not return errors, but the validator does. So if you see this is a 4-step thingy, yeah. So the steps 1 and 4 can return errors, steps 2 and 3 do not. So the parser has to receive text. If the sheet type message is not string. The message must be the text, but instead is and now I'm going to do it like this. It will be a parser. Let's just have one variable for the functional programmers out there. We will override the variable. It's the parser. If output error, return output. Then I am going to apply the sorter and the dedotter on output, right? Yep. And actually, well, I can just do the whole thing because why not? And then with validator, honestly, I do not need to sort before I validate, do I? No, I don't. I thought I had to, but not really. But it's good because then I always get things in the in the order it should have been written. So yeah, let's keep it like that. Yeah. Validator, sorter, dedotter. And then just return the output where it has an error or not. And this should not return true. It should return the actual paths. Yeah, brilliant. Yeah. I love this. I'm really happy with this. We have a parser. We do have a parser. Therefore, now what do we do? Let's just take a step back. Actually, I'm going to stop right now and I might do a short episode in a bit. But I think this is a good moment to stop. Thank you for watching. Hello again. I changed my mind. I'm going to continue the episode. So let's just do a bit more design. Let's just do some design, like take a step back. We now have a parser, a proper parser. Well, proper. Yeah, a sufficient parser that goes from text that could potentially have all sorts of issues, and then we flag those issues if they appear. We only flag the first issue, which I think is okay, because I kind of have a feeling that when you have more than one issue, all bets are off, and then you're better off stopping, fixing that, and then moving on to the next one, which is an interesting property, because in some when all bets are not so off and you have some errors, but the level of error is bounded, you could still presumably try to identify as many errors as possible. But when you're parsing something and the lines might just be completely wrong, I don't see a point in returning multiple errors. We'll see. For now, let's just go with the tender cooked tough chicken approach and return the first error and stop there. So we have that. We have a sufficient parser. What do we do with it? So we are still trying to implement just two calls, get and put, right? That's it. And we have older code. We have the parse, the spaces, prepend, have all this stuff, which will probably throw away most of it, but not all. My God, yeah. Yeah. I am just looking at the older code. Well, this is fine because this is the UI. It's fine. And these are the tests. But man, this is yeah, we were trying to do this. What did we learn from this. Like we learned that we need to have a parsed internal representation of for data, because doing it in text is just, yeah, too much work. And yeah, it's all paths. The paths are very, very powerful. Well, not powerful. True, shall I dare say? Yeah, the paths are a true internal. Paths are a true representation of for data. Well, not the only true one, but the much more readily a representation that you can readily manipulate and validate, versus text is not so much like that. So we need get and we need put, right? So yeah, let's just think of what do we need to re-implement get and put. So, and why am I so sure we're going to be working with paths? I'm sure we're going to be working with paths because also when we store this in a database, we're not going to store it as text. We're going to be storing it as paths, because paths you can index, right? Am I still recording? Yes. Paths you can still you can store in a database, and then you can index them and just go to the nth element, and instead of having to read the entire thing from scratch every single time. So it even makes sense to keep this in JavaScript as well, have an internal representation rather than depending on what? Depending on the local storage. Yeah. I mean, yeah. Let's just do it. Let's just keep it as an array of arrays, a list of lists, and work from there. So what do we need to do with get? How will get work? With get, I am getting, I'm looking at the old code now. Basically, when we're doing a get, oh my. Yeah, I'm just thinking, yeah. Sorry, I'll share in a minute. Yeah, we need to do this better. So it's going to be like this. So we get a message. The message always goes to the parser. But I'm going to get some coffee while I walk around with the computer, in the interest of... oh no, I have some coffee, never mind. Sorry, I was wrong about the coffee too. So... So the messages are always incoming. The message is always incoming, gets parse. Then we decide to call either get or put for now. Yeah, because put is a call that is not in the data space, but we still implement it. Yeah, we'll get to that a bit later, I think. For now, I want to get something going. Actually, I want to design it. Let's just if actually wait, it gets parsed, then we check whether at is the first element of the first path. If it's not, we give an error. It's like that's not a call. Otherwise, we check if the second element of the first path is put. If it is, we call put. Otherwise, we call get. But wait, now we need to do more validations, right? Or we can just let get and put do those validations. I want to do assign, but now I feel like coding and like designing on what I do it. So we have the parser, which is very lean, well, very small because he has 4 helper functions. So we have the parser. So you know what? Let's just override the message. Message. And here I'm going to do it like this. If message 0 if there's no length, return nothing. Sure. If message length, message 0 is not an add, return this one, right? Look at that. Look at that convergence. Yeah. This we don't need because we go with the parser. Actually, these are the paths, they're not the message anymore. Yes, sir. That's proper naming. I want to validate that there's only a call and nothing else, and everything else is inside the call. Stop not paths function path. If the first element of the path is not an add, extra keys is not undefined, return error, call no, call must only have this has a key. But it has a key. Keys, no extra key. Yeah, sure. Let's do it. Path 01 is put. Then we need to basically get everything out. Yeah, we need to get, in the case of the should a call always have one path? No. It could have multiple ones. If you're passing, let's say, a hash on a put, but on a get it should always have one. It should always have one. So if we have a put here, I guess, you know what? The parser should not do this. This is the function which is the call. Yeah, so we call the parser. Yeah. And now we validate that if it's a put, all this of this must start with yeah, so it would be like this. The call put call must not have extra keys. It's a key, yeah, perfect. And then I just return put I need to do this. I'm going to go through the paths and then just going to slice them. Is it 2? Yeah. So remove the add and the put. Yeah. And that otherwise I just call get with the paths. Wait, there should be a single path in a get. I cannot have multiple, right? Yeah, otherwise you'd make 2 get calls. Yeah, for now I don't think it makes sense. If paths length plus 1, it has a path. And let's just put the second path. Yeah. Return get. Give me all the paths. There's some repetition here, which I could factor. But that's really the call function. So, oh, look at that. We can just get rid of so much stuff here. The trimmer, we might have to implement something like that. Okay. So I'm thinking now that let's store the paths, not just the for data, not just the text in JavaScript memory, not just the text in local storage. Yep. Then both get and put operate on the paths already in the data space plus the parsed message. So basically get and put are like JavaScript, get and put are like JavaScript cell macros in that they operate on paths. And put returns an OK and creates a side effect. Well, not a side effect, it just updates the data space. And then get gives you back text. It doesn't give you back paths. So we need a mechanism to convert paths back into text. So we'll implement if we had the parser, we could call it an unparser, a reverse parser, unparser. Which one is more funny? Unparser, deparser, a deparser. Nah, let's just call it the texter. Yeah, texter. So we're gonna implement the texter, paths to text. Get is gonna be really simple. I'm just gonna design here. You go through all the paths in the data space and filter out those whose first n elements are equal to the n elements of the single path received as the message, right? That's going to be an initial version, because at some point I might need to do gets, like get from the inside, like I need to implement that what I call semi-lexical scope. But a first version will do this. This is going to be fun. Yeah. And then just run the texter on the output and return that. Not run, call. Yeah. That's a get. The put. Dude, the put is trivial now. You need to validate. No, it's not trivial, but you need to override whatever you need to override. Overwrite at the fork point that we need. And return OK. Implement the text. Okay, now I'm gonna be done. Thank you so much for watching. This was a great episode in terms of output, at least. See you next time.